Least common multiples. The least common multiple of two given numbers is the smallest whole number that is a multiple of both of the numbers, both of those given numbers. Let's look at an example and find the least common multiple of 6 and 7. First, we want to find the multiples of 6. These are 6 multiplied by 1 equals 6. 6 is a multiple. 6 multiplied by 2 equals 12. 12 is a multiple of 6. 6 multiplied by 3 is 18. 6 multiplied by 4 is 24. 6 multiplied by 5 is 30. 6 multiplied by 6 equals 36. 6 multiplied by 7 is 42. 6 multiplied by 8 is 48. We really don't know how far we have to go because we're trying to find one that's a multiple that's common with the multiples of 7. Let's just stop and try to find the multiples of 7, and if we find one that's common to both lists, then we can stop. So 7 multiplied by 1 equals 7. 7 multiplied by 2 equals 14. 7 multiplied by 3 is 21. 7 multiplied by 4 is 28. 7 multiplied by 5 is 35. 7 multiplied by 6 is 42. 7 multiplied by 7 is 49. You probably noticed that I have 42 in that list and 42 in this list. So we have found our common multiple, the first one. Until we get to 42, we don't have any common multiples on our two lists. So now we know that the least common multiple, the smallest multiple that's common to both 6 and 7, is 42. So the least common multiple of 6 and 7 is 42. We could just have listed those multiples. There are a few different ways to look at this, but first we need to remember some of our past definitions and some concepts before we go back to look at the different methods of finding the least common multiple. All right, so first we want to remember that a prime number is a whole number greater than 1 that has only two factors, 1 and itself. And we can remember that 2, 3, 5, 7, 11, 13, and so on are some of our prime numbers. A composite number is a whole number greater than 1 that is not prime. In other words, a composite number is a product of 1 and at least 2 prime factors. And we want to always remember too that the whole numbers 0 and 1 are neither prime nor composite. They're in a special class all by themselves. All the other numbers are either prime or composite, but 0 and 1 are neither of those. All right, now we remember also about factors. Factors are the numbers we multiply together to get a product. So to look at this, let's look at what are the factors of 12. We know that 1 times 12 is 12, 2 times 6 is 12, 3 times 4 is 12, and 2 times 2 times 3 is 12. So these are 4 different factorizations of 12. These are the 4 different factorizations of 12. Listing them smallest to largest, the factors of 12 are 1, 2, 3, 4, 6, and 12. So when we're looking at the prime factorization, that's the process where, given a product, we find all the prime factors and that when multiplied back together give us the original product. So in our looking at 12 up here, we see that for 12, the prime factors are 2, 2, and 3. That product gives us 12, and all 3 of those are prime factors. So let's find the prime factorization for those numbers we found before. So let's look at 6 and 7 here. So we'll find the prime factors of 6. So I like to use a factor tree. So we put 6. We know that 2, because 6 is an even number, 2 is a factor of 6. 3 is prime. These are the prime factors of 6. 7 is a prime number. 1 really isn't a prime, so we really don't even consider that. So the prime factor of 7 is just 7. All right, let's look at this Venn diagram and we'll show these two numbers in that. So this is 6 and this is 7. And I'm just going to circle here that the green here, we're going to put the factors of 6, and in the yellow, we're going to put the prime factors of 7. If there's any prime factor common to 6 and 7, we'll put it in this intersection in the middle here. But we don't have anything common, do we? Prime factors of 6 are 2 and 3, and the prime factors of 7 are just 7. Now if we multiply these 3 together, 2 multiplied by 3 multiplied by 7, we get 42. So that is the least common multiple. And this one, all right, let's look at another one, and a little bit more involved one. So let's find the prime factorizations of 32 and 48, and then show them in the Venn diagram and see if we can find the least common multiple. So again, I'll use my factor tree. I have 32. And we know it's even, so we have a 2 in it. 32 divided by 2 is 16. 16 is still even, so we divide by 2 and we get 8. We divide by 2 and we get 4. And we divide by 2 and we divide by 2. All right, that's the prime factorization of 32. Let's look at the prime factorization of 48. 2 and 24. We have 2 and 12, 2 and 6, 2 and 3. So here I have, we can see 4 2's. And here I have 5 2's. But common to both of these lists are 4 2's. So when we plot we'll put 32 in this Venn circle and 48 in this. Okay, so using our Venn diagram here, we'll put what we have common to both lists, 2 to the 4th power, in the intersection of these two diagrams. So 2 to the 4th is common to both of these. Now 48, we have 2 to the 4th multiplied by 3, so we need a 3 on this side. So 2 to the 4th multiplied by 3 is 48. All right, and 2 to the 5th is 32. We already have 2 to the 4th, so we have one more 2 that we need out here. All right, this is our Venn diagram description of these two numbers. We know that if we multiply them together, we'll get the least common multiple. So I have 2 to the 5th. We know that's 32. 32 is 2 to the 5th. And now we're going to multiply that by 3. So 3 times 2 is 6. 3 times 3 is 9. The least common multiple of 32 and 48 is 96. So this is one method of finding the least common multiple using prime factorization and a Venn diagram. Another method of finding the least common multiple is using division of primes. So this process is we find the smallest prime factor of any of the given numbers, and we divide by the prime. If the number is not divisible by the given prime, we bring it down to the next level unchanged. We continue until we have all ones. The least common multiple is the product of the primes. Okay, let's look at this one. It's probably easier to see as an example. So we have 32, 48, and 30. So we list those across the top. I'll draw a line here, and I'll draw a line down where here I'm going to have my first prime factor. Since they're all even, the smallest prime factor is 2. So 32 divided by 2 is 16. 48 divided by 2 is 24. And 30 divided by 2 is 15. Okay, so now these two can be divided, are divisible by 2 because they're even. This one's not. So let's see what happens here. I take 16 and I divide it by 2 and I get 8. 24 and divided by 2 is 12. 15, since it is not divisible by 2, we just bring it straight down, and that's what our star up there said. All right, so now another one. We still have a 2 common to these two, so we will divide by 2, This will be 4, 6. Just bring that 15 down. Still a 2 in these two, so 2. This will be 2. 4 divided by 2 is 2. 6 divided by 2 is 3. And bring that 15 down. Okay, so now 2 and 3, those are prime factors. So we can bring a 2 out here, then this makes this a 1, and then 3 cannot be divided by 2, so we just carry that down, and we put 15, bring that one down also, because it's still not divisible by 2. All right, now these two have a prime factor of 3. This will be a 1, this becomes a 1, and this is 5. Okay, so now we have only this 5. We put the 5 out here, and now we have 1, 1, and 1. All of the levels are 1. So we're done. It's the least common multiple then would be the product of these numbers. So the least common multiple of 32, 48, and 30 is 2 multiplied by 2 multiplied by 2, 5 of them. 1, 2, 3, 4, 5, and then 3 and 5. Okay, so we know that 2 to the 5th power is 32. We did that just a minute ago. So 32, and we have 3 multiplied by 5, that's 15. So 32 multiplied by 15 is going to give me my least common multiple. So let's do this out in the 32 multiplied by 15. 5 times 2 is 10. 15 plus 1 is 16. A 0, that's 2. And 3, 0, 8, 4. So the least common multiple of 32, 48, and 30 is 480. So we can look at this again, finding the least common multiple by division, using division by primes. The least common multiple of 32, 48, and 30, and the process again of find the smallest prime factor of any of the numbers, divide by the prime. If not divisible by the given prime, we bring down the number to the next level unchanged. We continue until our last level here is all ones. The least common multiple then is the product of the primes. So the least common multiple again of 32, 48, and 30 is 2 to the 5th multiplied by 3 multiplied by 5, which is 480.